So let's talk about what we call immune hypersensitivity. So we're not going to call them allergies anymore. I guess we still are, but we're going to think of them as hypersensitivities. Okay, so this is saying that the immune system is doing its job, but it's doing it too much. So excessive or inappropriate activation of that immune response. So ultimately, the body becomes damaged by the immune response rather than by the antigen itself. So here's an antigen that may be harmful, or it may just be a normal body cell protein, like if it's autoimmune, and your immune system says, oh no, nope, not going to have it, and then over responds, and that can cause more problems. Okay, so there are 4 types, and we're going to go through all 4 of them. There's type 1, which is immediate, type 2, which is called antibody-mediated. These we'll describe each of these. Type 3, which is immune complex-mediated, and type 4, which is cell-mediated. So let's dig a little bit more into what all of those mean. So I guess we're going to dig a lot more. So type 1 hypersensitivity, we said that that's immediate. So those are our allergic reactions in general. So remember that. It's really our allergic reactions. They're mediated by that immunoglobulin E. That's why I mentioned it before and now. So you'll remember kind of how this happens. The IgE is first, it's actually first produced as IgG from the plasma cells. Remember those B cells, those activated B cells, which are plasma cells. But then it's converted to IgE, so it specifically will insert itself into mast cells, which we can see that over here. So this mast cell here did not make those antibodies that are on its membrane. They were actually made by plasma cells, and then they insert because the constant region, or the bottom part of that, is set up to actually bind to little receptors that are on the mast cells. Okay, so that's what happens. The IgE inserts itself into mast cells, and then wherever those mast cells are, that antibody is going to react to whatever it is, pollen, whatever the allergy is. So local or atopic reactions, urticaria, hives, rhinitis, hay fever, atopic dermatitis can happen if it's a rapid response. Like if something, I'm saying this because type 4 is a slower response and can also cause some dermatitis, but atopic dermatitis, if it happens very rapidly, like as soon as something gets on you and you start itching, like immediately, then that would be considered more of a type 1 hypersensitivity because it's that very rapid degranulation of these mast cells. Okay, we're going to see later things like nickel allergies, even like poison ivy. Those are delayed. That doesn't happen right away. That's not just boom, we're activating mast cells, they're exploding and causing us to itch or whatever and swell. Okay, bronchial allergic asthma. That may be associated with like an anaphylactic response, or even anaphylactic shock if it goes on long enough. Some food allergies, if it's rapid, if it happens just very, very quickly. All right, so the process after first exposure to an allergen, so it's just like we saw earlier. The first exposure is where it has to go through all of the work. Okay, so that IgG will ultimately be produced. And then it will be converted to IgE, and then that IgE antibody coats the surface of mast cells. So the first exposure may not be much of a response at all, if it's even noticed, but your immune system has noticed and said, this is not supposed to be here. So we're going to make sure that if it shows up again, we've got these antibodies against it just waiting in the mast cells. And then the next time you're exposed, so when subsequent allergen binds, the mast cells will immediately release the mediator, such as histamine, which can cause that itching, heparin, proteases, cytokines that can amplify the response. It might start pulling in eosinophils, which can also amplify the response. And that can be really, really bad. I mean, that can kind of get out of hand, and that's where we see this systemic. If it moves into this systemic response, that's where we start seeing anaphylaxis. Okay. All right, so this is kind of just a different way of looking at the same thing. So IgE can provide protection from large parasites. So yeah, well, that's what I just mentioned. It initiates an inflammatory reaction to attract those eosinophils. So we see an eosinophil kind of moving into the tissue where the mast cell had degranulated and released its cytokines. So when it's produced against innocuous or harmless environmental antigens, they are a common cause of allergies. So I say harmless, but they're obviously harmful if your immune system decides they are, but they shouldn't be, so that's innocuous. So so that's our type 1 hypersensitivity. The constant portions, or the bottom part of this little Y, little stalk that it sits on, that's the constant portion, and that's what allows it to bind to these mast cells. Okay, so a type 2, so those are type 1s, allergies. It's always good to like have a catchphrase that kind of gets you, makes it easier to remember. So type 2 hypersensitivity, so antibody mediated. Okay, so this is a big one. Okay, so this is what we a lot of times, think about with when we have like a response to a virus or something like that. Okay, so, but in this case, this is a hypersensitivity, so we're going to see where it goes. So IgG or IgM attack on antigens on cell surfaces. So antibody mediated, that means that B cells made them, and they are going around and they're attacking cell surfaces. So the reason we say it as cell surfaces is because it is attacking specific tissue. Okay, so by that, I mean that if you have, in this case, well, we talked about, I think myasthenia gravis, so it's attacking the acetylcholine receptors on neurons. Okay, so that's specific to those. It's actually attacking something specific. Thyroid, so in Graves' disease, oh, I guess I have them listed down here. In Graves' disease, IgG, so immunoglobulin G, that's just the little Y-shaped one, will bind to thyroid glands and will cause will increase the activity of the thyroid gland. Okay, normally we think of an antibody destroying things, but in this case, by binding to it, it actually turns up thyroid hormones, and then you have hyperthyroidism because of this autoimmune disorder. Okay, this type 2 hypersensitivity. Myasthenia gravis, we mentioned that, binds to acetylcholine receptors. Rh disease, so that's that pregnant Rh negative woman may launch an IgG attack on her Rh positive fetus. Right, and I also mentioned that differing blood types are safe because IgM uses IgM and that can't cross the placenta. Okay, so that's the second time we mentioned that. And that's kind of an important thing to understand because a lot of people ask questions about that. It's like, okay, why does the mother attack the fetus for the positive and negative blood type, but not the fact that the baby's a B type and she's an O? Why doesn't she attack it then? And that's because that's a different immunoglobulin. That's IgM, and it can't cross, but that IgG can cross. All right, so let's see. Did I skip? All right, so this is just kind of showing an image, if that helps, of how this is tissue specific. So there's our antibody activation. Let's see. So here we see antibodies against the let's see, thyroid stimulating hormone. So so it binds to the thyroid stimulating hormone, which is going to activate the thyroid gland. Okay, that's what we see here. This is myasthenia gravis over here. I'm not sure what this one is. Oh, this is just I guess activating complement and causing destruction. I'm not sure where, but yeah. Okay, this is, yeah. All right, so let's go on to type 3. 3 is, okay, it's easy to get 2 and 3 mixed up, so let's not do that. Remember, type 2 was specific to tissue, and we went so far as to say cell surface. Okay, so that is specific to a certain type of tissue. Type 3 isn't specific to a certain type of tissue. It is specific to a pathogen, but these pathogens are just floating around in the blood. So if you can imagine that, the pathogen floating around in the blood and the antibodies floating around in the blood, there is no specific tissue involved, but that antibody will see that antigen and click to it, and it will bind to it. And then more of these antibodies will bind to more. So it's this fight that's going on as they're floating through the blood. Okay, there is no specific tissue that's being targeted. So they're up there fighting, floating along, and then they build up into this complex. That's what we're calling it, and that will then kind of move off to the side, or it may get trapped somewhere like in the joints. It may get trapped in the glomerulus of the kidney, but it will get trapped somewhere, and because these are immune cells, it's going to launch an inflammatory response. It's going to launch an immune response. Cytokines will be activated, and just everybody's going to think something terrible is happening here. So it's inflammation that happens. But it isn't because the joints were targeted or the glomerulus, the kidneys were targeted. It just happened to be that that's where this complex fell out of solution. Okay, and it's predictable where they're going to fall out. Okay. Okay, so free-floating antigen plus antibodies, circulating immune complex. Then that circulating immune complex deposits on the wall of blood vessels, and it activates complement, or it activates an entire inflammatory response, lead to recruitment and activation of inflammatory cells that then release tissue damaging products. It could cause vasculitis, blood vessels. I mean, it's landing on the side of a blood vessel. It's going to cause inflammation wherever it lands. It's going to cause problems. Okay, so blood vessels can be damaged. Okay, and I have a note. I'll say it again. This is not tissue specific like a type 2 because these antibodies are attacking things floating in the blood, not specific tissue. So this antigen antibody complex may then settle out of the blood into certain tissues, but that's not predictable. I say it's not predictable, but we kind of know. Okay, so a lot of these are kind of show up the same way, and that's what we're going to talk about here, I think. So antigen antibody complexes are formed in the circulation and are later deposited into vessel walls or extravascular tissues. Okay, so that's just a fancy way of saying what we've already said. The complexes circulate and then fall out of solution. Inflammation at the site where they are deposited damages blood vessels and tissues. Ultimately, it could cause damage to the kidney. So this is some of that kind of predictable, kind of where we see it a lot. So kidneys, so a disease called glomerulonephritis. It's an inflammation of the glomerulus in the kidneys, and this may happen because of these antibodies that are floating around that then get attacked. So consider that filtration at the glomerulus and how it kind of gets hung up in those podocytes and that kind of area, and then it can cause breakdown of tissue. Joints, rheumatoid arthritis is also kind of the same thing. It's not that rheumatoid arthritis is an autoimmune disease, but it isn't that the joints are specifically being targeted. It's that free-floating pathogens, antigens, will settle out, and that's where they kind of end up is in the joints. Okay. So we say that it's not organ specific because it's not attacking this specific cell types. I like to put that in there because that's where people mostly get confused. So the causes, most common is antibiotics. So you take an antibiotic and that's going to, the body may recognize that and say, whoa, that's not supposed to be here. And so it will launch an attack against those antibiotics. And by the way, those are people who are allergic now to antibiotics because they've had a response. But also different foods could cause this. Drugs and insect venom is something I read. I thought that was kind of interesting. So whatever is causing a pathogen out there that your if it's floating through the blood and your immune system recognizes it and attacks it, that's considered a type 3 hypersensitivity. So it can be autoimmune if the immune system confuses a free-floating self molecule for an invader. Okay, so that can happen a lot of times, and we never really know for sure what triggers it. but somehow the immune system gets confused and says, that's a pathogen, that's non-self, when really it isn't a pathogen and it is a self molecule. Okay, so maybe there was a virus or something that had a epitope that looked close enough to something that was self, and so the immune system gets confused and says, well, I'm pretty sure those are the same, but they're not. So examples, more examples, autoimmune vasculitis. So vasculitis is vascular, and so it's inflammation of the blood vessels, which makes sense in this case. Glomerulonephritis, mentioned that. Systemic lupus. Lupus has, I don't know, it's never lupus, but lupus has a lot of different symptoms associated with it, and that's because it's this type 3 hypersensitivity, and so it can have effects in many different places. With the vasculitis, it can affect the kidneys, so lots of different possibilities there. And then rheumatoid arthritis is another one that we kind of mentioned. All right, so I kind of put this up here. We can go through it quickly. Systemic lupus erythematosus, SLE, chronic multi-system inflammatory disease. And hopefully we're seeing why, because it's not attacking a certain tissue. It's just in the blood. And then it falls out. So arthralgia, sure, joints, yeah, that's a place where these complexes can fall out. Or arthritis, vasculitis and rash, sure, blood vessels. Renal disease, yep, these complexes can fall out in the kidneys. Hematological changes, cardiovascular disease, I suppose it could fall out there too. Okay. Rheumatoid arthritis, circulating immune complexes containing antibodies, also more common in females, not relevant to this class. Manifestations, redness, swelling, and painful joints. So that's rheumatoid arthritis as opposed to osteoarthritis. Rheumatoid arthritis is the autoimmune one. Okay, the last one here, type 4 hypersensitivity. Okay, this is also associated with some things we would call allergies, but it could also be autoimmune diseases. So let's see what the difference is. The difference is that it's T cells. Okay, so think about it. The rest of them have had some sort of association with antibodies. Okay, type 1 was IgG turning into IgE. Those are antibodies. Type 2 was specifically attacking tissues, antibodies. Type 3 was antibodies in the blood, so antibodies. This one is type 4. Okay, so we call it cell-mediated or a delayed response because these T cells take a little longer every time. So cell-mediated, T cells respond to an antigen and then they travel to that location to activate a more sustained immune response at that location or tissue type. So direct cell-mediated cytotoxicity. So really what we're talking about, we can be talking about helper T cells, but helper T cells really kind of just trigger that response as we have there. So they're sending out cytokines and they're kind of turning up the response and maybe causing a signal to be sent out for other immune cells to move in. In this case, cytotoxic T cells will move in, and those are the ones that will actually cause damage to cells in that area. So viral reactions could trigger this as well, and then ultimately it may involve macrophages. So macrophages may start getting into the game and come down and also starting to cause damage or an inflammatory response, I guess we should say. So we call it that delayed type hypersensitivity. Some examples: contact dermatitis, poison ivy, or nickel jewelry. So I happen to have allergies to both of those, and ever since I was a kid, have known that when you are exposed to poison ivy, you're not affected right away. If you start to itch right away, it's not poison ivy, because I would go through poison ivy and then the next day, minding my own business, sitting in school, in grade school, I would suddenly just start turning red all over my body and everything itched. Okay, it didn't necessarily move that fast, but it was noticeable a day after, maybe. Nickel jewelry, same thing. You have to wear it continuously. I also have that. That's fun. My T cells are awesome. So, but that also causes a dermatitis, contact dermatitis, where it touches you. TB test, I think there are different types of TB tests, but the one where they kind of put it in your just under the skin and cause a little bubble to come up, and then you have to go back and have it checked later. That's a type 2. That's delayed. That's a T cell mediated response. So those T cells have to get there and then cause that inflammatory response. Multiple sclerosis. So in type 1 diabetes, these have also both been seen to be autoimmune diseases where cytotoxic T cells, for whatever reason, don't like myelin, or they don't like the beta cells in your pancreas and cause diabetes. So multiple sclerosis, it's your body attacking itself. Your T cells have gone rogue. They've discovered something that they don't like, and they will kind of activate it. And so you have to take things that kind of shut down those T cells, which there are medications that will specifically reduce T cell, and remember this, will reduce T cell activation and activity. Okay, and that's a lot of times for people with autoimmune diseases, they're taking these medications that reduce T cell activity. Diabetes, again, same thing, beta cells in the pancreas. All right, and I have that last little note there that this is the only hypersensitivity response that does not involve antibodies. And that is it for this section. Thank you. Have a good day.